Greetings, programs. Welcome to Friday's Lunch and Learn in the virtual sense at improving. I'm Harold Pulcher. I have a person helping me on the backside that'll be answering questions. That's James. He's awesome. Anytime you have a question during this, please type it in the channel. Type it in the chat. He will relay that to me. We'll have it going. I really like lots of questions and all those sorts of things. But before we get started in our main presentation, I am a senior consultant here. I am a Microsoft MVP, and I like to do lots of different things. But before we do all that, we're going to go a little bit into a little bit of improving. We do lots of things. We do more than just software, and we do a lot of training. If any of these virtual training classes will be available are there, here's a smattering of a couple, 2 or 3 coming up. We have a lots more. Please go check them out. And you got an email down there at the very bottom where you can send them some inquiries and all that sort of thing, right? We're always looking for awesome people. And this is fresh, hot off the presses as of this morning. You'll notice there's locations around here, and I am from the Dallas office, but improving is all over the place, and at least in North America. Yeah, almost all over the place anyways. And then with the day of when our day of where a lot of people are doing remote work, it doesn't really matter where you live these days. If you fit one of these, you think you fit one of these offerings, or if you go to improving.com and go to the careers section, you'll see a lot more offerings. If you think any of that will fit any of that, send us a note. Improving.com/careers is the web page, and careers@improving.com is the email address to send to. Speaking of what I said, we're almost everywhere. We have 14 offices, or we call them enterprises, around North America. A couple of the newest ones in Mexico. If you're close to one of us, please come by and see us. Please come by and see us. It's awesome. All right. I know that you're here for the Lunch and Learn. Just in case you didn't know, we've done a bunch of these things, and you can register for them. And also, if you notice, we've got a bunch of all the past ones that are out in the on YouTube and that kind of stuff that you can go see and see all the glory of all the stuff's going on. Oh, I forgot one thing. I'm not properly lit. How's that? So, why is everybody here today? Talking to me, I guess. Let me talk, or listen to me talk. 1 second. Got it. This is my latest presentation going on with .NET 5 with a slice of pie. I like to play with hardware. I like to play with software. I think the combination of both are lots of fun. They can be fun all by themselves, but when you throw them together, you can do lots of fun things. And yeah, that's a wonderful picture of a Raspberry Pi there. In real life, they look much better than that. If you're going to take a picture of a slide or a screen grab or whatever method you'd like to do, this would be the screen to grab. It's got lots of pertinent information, as we like to say. You got my name, you got my Twitch handle, or Twitter handle. You have my email address at Improving. You got my YouTube, that I do a video on occasion. You got my Twitch handle there, which I Twitch Monday, Wednesday, Fridays, 8 to 10 p.m. Central, and on various subjects. If you were watching the last 2 or 3 Twitch streams, you would have seen me developing this talk. When I'm not doing that, I'm building other things, which we'll look at here in a second. And for right now, if you'd like to catch up to me or actually get this entire slide presentation right now, that bit.ly link at the bottom with .NET-Pi on it, that's my GitHub repo that has all this, has the slide on it, has all these slides, has a number of resources that I use to to develop this talk, and as well as an outline file that has way more information in just a scattered thing. And pretty much, if you imagine throwing just spaghetti in a bowl of information, that's what that is. And I collected a bunch of links and that sort of thing so that we could, so I could boil this down into something useful, or at least attempt to be useful. All right. All right, one more second. Okay, hopefully I've got it. I'll put that slide back up if you want to. So this is our agenda that we're going to go over today. We're going to go a little bit over the overview of .NET 5, and then we're going to go over the requirements of what you'll need for this talk. And we want to walk through some setup, do a little bit of a hello world, and we're going to make that hello world experience better. And we're going to take a look at one of the projects I've made over the last few months. I say last few months. It didn't really take all that long, but it took a little while because I worked on little sections and figuring out what I want to do and how I wanted to do things. And at the very end, I'll ask you to take some steps and take any questions. And speaking of questions, like I've said before, any of these. Any question you have, just shout it out, type it in, that sort of thing, and I'll be happy to answer them as we go along. And I'm specifically making time at the end to address any of those questions as well, and I'll address them as I can as I go along. If it gets too long, then we can take it offline. I've got some other mechanisms that you can talk to me with. All right, so let's get going on this thing. I suppose you know that .NET 5 came out in November, general availability, and what does that mean? That means it's ready to go as far as Microsoft is concerned for production release. They want you to put it into things. They want you to put it into projects. They feel safe using this thing. Are you not going to have any problems? I can't say that. What I can say though is they've done all of their testing and they believe it's stable enough for production ready code. And it's something about Microsoft. A lot of times they use their own, they eat their own dog food, so to speak. So they have had to be using .NET 5 for a while before you even see the light of day. So if you look at the idea of way .NET 5 is coming, it's basically any platform, any application, any development environment, and a single entity for them all. You had the UWPs, the WPFs, you had the IoT core, all that stuff was all fragmented, and the idea they brought it all together and going forward. And so you can see the various applications that you can target, that they've anticipated you target, and a number of the tools from the Cadillac Visual Studio all the way down to the bare minimum command line, which we're going to be using Visual Studio Code and command lines interfaces today. Now, as far as the .NET schedule goes, we're currently .NET 5 is general release in 2020, and it is not something called LTS, long-term support. If you're on 3.1 now, and you don't need any of the new features of .NET 5, then there's no really good reason to change. I'm not telling you not to change because we all want the new hotness, but it's going to be LTS, which means it's going to be supported for a long time. I think at one time that meant 10 years or so, but I'm not sure if that's the case these days. I haven't looked. If you'll look, our next LTS is going to be .NET 6, and that'll come out in this year in November. That's when it's slated. Whether it's going to hit that date or not, I don't know. We'll see when we get closer, but they've been pretty good. So every other release, every even release is an LTS release. So you can be confident with an LTS release, you'll have a long time span to do all the development and support that you need to do. But today, we're not talking about all operating systems. We're talking about Linux operating systems and running .NET 5 on it. These are all the various distros you can use. Various distros you can use on it. If you'll look at how the life cycle works, you see down the right hand side over there, the life cycle of this distro support for these different versions of the Linux OS is based on the life cycle of the OS. So like we'll be using Ubuntu 20.04, which is an LTS release from Ubuntu, and today, and the lifecycle support for that, as long as Ubuntu is supporting it, so will .NET 5 support that. That's what Microsoft says. You'll also see the architectures that are available. x64, awesome. ARM64 and ARM32. What you're going to find is when we start doing some installs, if you're running one of these, you run a distro on a x64 based system, you have install scripts. On the ARMs, especially with Ubuntu, you don't. There's a manual install, and we're going to go through that. And as I say this, and I was prepared for this talk, yes, on the 16th of this month, they've now updated a bunch of scripts, and they're supposed to just work. And I haven't had a chance to check them, so we're not using those today. But if you find them, you want to update me, please let me know. And I'm always good about it. Let me check my time. Got it. Okay. So here's the requirements. You have to have the following to do what we're going to do today. You got to get a supported OS, in this case, the 20.4. You'll need the .NET 5 SDK for your OS, and you'll need the Microsoft dependency package for that OS for .NET 5. You'll see where you install these things. I'm using a Raspberry Pi 4 today. Pi 3s will work. Pi 2s, there's a current bug, and I think on the Pi 3 there may be a bug. I ran into a problem when I was playing with it a little bit about a month ago, and so I've got the Pi 4 because I had it laying around, and I've been using that. I have not gone back to a Pi 3 to check on it. I say all that, the talking head is actually running on a Pi 3, and we'll see that working. Your favorite Linux editor? I like VI. You might like Emacs. I don't know if that's still a religious battle going on. That's probably as old as the spaces versus tab religious battle. But if you don't know what Emacs is, that's okay. Linux editors these days, a lot of people like Nano, and I think Pico and a few others out there, and they look at VI. Oh, I'm sorry, VIM, which stands for VI Improved. Like, I just knew it as VI. Been around a long time. You're going to need a network question, like a network connection. I don't know why I had to say this, but I felt the need to stick it in here. You're going to have some way to get all this stuff onto the Raspberry Pi, and you'll need to have access to root on whatever the Linux OS you have. Now on the right hand side, you have a nice to have, which and I'm going to say it's nice to have, but yeah, you need to have Visual Studio Code. You can do this in Visual Studio Community as well, but we're not talking about that today. I'll leave that as an exercise to a student. You'll need a couple of extensions, most notably the Remote Development Extension Pack. So, and I'll show you what it looks like in the demos, but it's just an extension you go install, or you can go to the NuGet package, NuGet's repository, and install it yourself on a Visual Studio Code, or you can do it, click the button. You need access to an SSH client. For a long time, I used Putty. Putty was the go-to forever and ever and ever. And Macs have always had an SSH client because of the way they were built. And now OpenSSH is built into Windows 10. So you can just SSH and go. I would recommend, this is one of the recommend things, install the WSL2, that's Windows Subsystem for Linux, version 2. It's really, really cool to set at a command line prompt and just type Unix commands and have them just work. It's fantastic. I'm not using that today, but that's really a nice to have kind of thing, because all these techniques I'm showing you now, you can connect to your WSL2 instance and run that very similarly on remote debugging in a Linux environment, not even go on your own machine, not to go anywhere other than your own machine. If you're not using Windows Terminal, you're going to lose points. Everybody should be using Windows Terminal because it's just really, really cool. I mean, you're like, well, just command line's good enough for me. No, please. The Windows Terminal there's lots of fun things on Windows Terminal, and you'll notice I have a very specialized prompt, which, thanks to Windows Terminal on my GitHub, it makes things much nicer. And of course, you'll need .NET 5 SDK for your OS, in this case Windows 10, installed and updated. In that case, that's just a point and click and a download and a go. Right. So if anybody has any questions on any of that stuff, shoot them to me, and then we're going to start going through. I know it's 10-15 seconds between when I ask that and you may hear that and be able to respond. Shoot them my way, and then we'll get to talking to them. And in the meantime, we're going to go through some of the setup. Setup. First of all, you need to install the Microsoft dependencies. This is a command you need to do, and this is again why I wanted to say, hey, go pick up this PowerPoint slide from somewhere from my GitHub repo, because that's a lot to type and a lot to remember. I do know that. But if you look, see what it does, it's using wget, and this is on the Raspberry Pi. This is on your Linux where you're doing this. Is you go get the package, it's a Debian package, you go install it, and you're done. All right. It's specifically for this package is specifically for Ubuntu 20.04. Next, this is where you go get .NET 5 for any of your OSs. I took a snippet of the web page and cut it out over here. You got the URL right there, but if you look at the snippet, this is 5.0.102. This is the latest version of it. And if you'll look through the installers at the bottom here, you'll see the various things: Mac, Windows, the Linux, where Linux says package manager instructions. Well, if it's on the ARM side of this thing, or especially with Ubuntu, they want you to do a manual install. So in this case, we'll be looking at the binaries. And in my case, I'm going to do the ARM64 binary download, and that comes down as a tar bundle. And you'll see how hard this is to install. Really hard to install. So you pick your link there, you download it, you get this on the Pi, and if you want to do a curl, you can do that too. However you want to get it over there. Right, and then we need to install .NET 5 onto my Linux box, onto my Raspberry Pi. So that's all there is to it, believe it or not. You make a directory for it, and then you unpack the tarball into the directory and you're installed. That's it. Set up your environment. If you want to put that environment into your .bashrc or your ZSHRC or any of your RC files that you're currently using, you just need to set those .NET root and add the .NET place to the path. And if you're doing this and you want it to be system-wide, just not for your user, you'll need to switch that home.NET to a user share.NET, which is where the utilities and tools are expecting the system-wide .NET to exist. Okay, so question is, could it be that easy to do a hello world, right? So what I'm going to do is I'm going to stop this, and I'm going to show you what we'll be playing with today. So this is the hardware we're playing with. You're looking at the close-up over here, which is the talking head that...
I think you shouldn't have gotten out of bed today.
Yeah, the talking head's kind of surly. So let me show you what's happening here on the Raspberry Pi. So this is what the Raspberry Pi I'm talking to. Well, I got a little switch, a push button connected up to a couple of pins. This is a Raspberry Pi 4. It's a Raspberry Pi 4. It's currently mounted on something called a donkey car, which we use some AI to drive this thing around on its own. It's really a cool project, and I said go look up donkey car. I think it's donkeycar.org. The donkey car, and they have races and stuff with this. It's really, really cool. But we're going to use the Raspberry Pi 4 off of it to do our demonstrations today. And then when we come back to everything, I just want to show you what we're messing with. And then the talking head is kind of over here. I'll let him look over our shoulder. So how you feeling today, talking head?
I will answer you tomorrow.
Yeah. Okay. Yeah. Okay. Enough out of you already. So let's go back to the desktop. I only want to show you the hardware that we're talking to, because I don't have a head on this box currently. and there's not a good way for you to see that. So what you see in front of me right now is Windows Terminal Server, or Windows Terminal, not server, just Windows Terminal. I've got 3 tabs up. One of those tabs is I've got a top running on it just so I do some monitoring of what's going on. You can see what's going on in my on the Raspberry Pi. This is meant to be headed, so I'm using way more memory than I should, but basically it's not doing anything. You see the load average up at 0.02. I've got a local for my repo where we are. If you go pull the repo, you get something similar. If you'll notice the cool little blue and green banners, that's thanks to Windows Terminal and something called a Powerline font, able to set all that coolness up for me. What I want to show you now, though, is getting on to the Raspberry Pi. So I just SSH. Remember, SSH is now built into Windows 10. Ubuntu is the username I'm using because that's the default user you get when you do your install of Ubuntu, and my IP address, my local IP address. You see a couple things there, right? I did not have to use a password to log in. We'll go over how that works, but that's a requirement to make your life easier when you're doing this debugging. So now I'm here, and yes, I got aliased DOS commands. I could do an LS too, so whichever one you like to do there. I'm going to go into the examples where I'm showing all this stuff, and you see I've got two hello. I got a hello world, which I've already pre-built, and the push blink, which we'll do a demo in a minute. But right now I want to show you how hard it is to make this stuff happen. You need to make sure your .NET command's working, and then you need to if you'd like to see what SDKs you have available to you that you've got installed on the system, because the SDKs can live side by side and they work just fine. Really? Oh, forgot an S. I can't type. We'll try that one more time. Okay. So I've only installed one .NET 5 SDK, and it looks like I need to upgrade, but we'll get to that. So how hard does it make to make the .NET stuff work? So .NET new console, just like file new project console. I'm gonna give it a name. And I know this is difficult, and I know you think you may not be able to do all this. I'm joking. I'm joking. So now we have this new project. We're ready to go. And you think I'm not lying to you. Hello, improving. I got a program, I got an object directory, I got a project file. Project file looks the same project file you're used to looking at and running on Windows, running inside of Visual Studio, the whole works. If I want to run this thing, .NET run. That's all you need to do. And what it's doing now is going out there, looking at dependencies, that sort of stuff, and making compiles and compiling, and now runs my hello world. I forgot to mention this thing runs in Docker containers and all those other kind of things that you can imagine as well. So I'm going to VI my program CS. Yep. I understand that this is a trivial program, and you're right, it is a very trivial program, but it makes sure that all of your stuff is where you expect it to be in your paths, and it can run. So now I'm hello improving. That was a wonderful experience having to go in VI. Some people like to do this. Maybe that's better. Okay, not so sure about that, but that's all right. All right. And as far as directory structure goes, you'll look through here, we've got some directory structure. You saw the top directory structure up here that you've already seen. You have a debug like anything else, .NET 5, and you've got a whole bunch of junk down here. And I say, let's go see what that is. Bin, just like you'd have a bin directory. I've got a debug directory. I've got a .NET 5, and I'm there. I've got a number of things. So once I've compiled it once, I've got it compiled there. Or I can do one of these. Which is essentially what that other thing is doing, that run thing is doing on there. It's just packaged up. All right, I can tell .NET just to execute that DLL. And away we go. So that was fun, right? How much fun was that? Yeah, I got to laugh at my own self. So no questions so far, huh? All right. Yep, it can be that easy. So let's make this better. Right? You probably didn't think that was the best and most coolest experience, because one, I didn't show you any debugging. I didn't show you how to go figure out what's going on or where things logging. Didn't show you any of that stuff. So we're going to make it better, and this is how we do it. First of all, you need to install Visual Studio Code. You need to install the remote development extensions, and you need the C# extension. You just do. You just do. You need the C# extension, and once you get all those in there, it'll make your life lots easier. Plus, we're going to do a couple of more things. We're going to set up that SSH. You know how I logged in without a password? This is the start of how you're doing that. So SSH keygen is on your Windows box right now. Open SSH. The T says give me an RSA type. B says number of bits, and you need to create two of them. One of them will be ID_RSA. The other one will be you give it a file name of ID_RSA-root. These set up a pair of files. One of them is what you see, and the other one is a .pub or a public file. You want to copy the public files to your remote machine, wherever that is. In this case, it's my Pi. In your case, it may be a VM. Doesn't really matter. You need to get them there. I like SCP. Again, SSH, all in the thing. Then when you get them, then you need to ensure that SSH is you need to get them over to your machine. They're over there. It's great, right? Now, then you want to go to enable SSH access on the remote Pi. You may have already done this. You may not have done that because you've typed all this stuff in a console on the Pi if you wanted to. But I want to make sure you understand. Get it over there. I have no idea who the linuxguys.com folks are, but their tutorial seemed to be pretty cool and go through all the appropriate steps. And I wasn't going to write all them out here.
So Harold, you do have a question of if there's a GUI available also.
A GUI available for, on the Raspberry Pi? Absolutely. It's headed. It has a full, I'm going to assume you mean on the Raspberry Pi. Yes, it's full. You can run Visual Studio Code in the GUI directly on the Raspberry Pi if you wish. And then you can debug stuff there as well because you're right on the machine. Right, and the debugging is probably a little more simple than what I'm going through now, but a lot of times in a lot of projects I have, I do not have like you saw the donkey card that I showed. I've got no place to put a screen on that so I could see it. I can do some stuff in development, but as I'm having the robot eventually run around and do things, having the screen attached to it is just not going to work very well for me. So I've gone this direction with being able to remotely control the thing. So here's where it gets a little ooky. I hope that answers your question. If it doesn't, ask it a slightly different way, and I'll be happy to answer any questions. So here's where it gets a bit ooky, and the DevOps guy in me just freaks out when I see this. By default, Ubuntu does not allow root passwords because you don't have a password for root. You have to log in as a normal user, then become root, usually using the sudo. I call it sudo. Some people say sudo. I don't know. Whichever makes you happy, that's fine. That says, like some people say sudo, like su is super user, do this command, that sort of thing. But you give it a root, and then this is where these pub things come in. in your home directory and in roots directory, you have a .ssh folder. Inside that, you may not have a file called authorized keys. If you don't have a file, just make it. And both of these commands will make the file if it exists. If it doesn't exist, if it does exist, it'll just append to the end of it. Right? At that point, you get rid of the .pub files, and because they're no longer used, because they're now incorporated into the authorized keys. That's where your SSH client is going to look. Tell the SSH daemon that root can log in, and what you do there, you go edit that one file using your favorite editor. Do a permit root login yes. You'll need to find the permit root login. It's commented out normally. You need to uncomment it and put the word yes at the end of it. Save the file, and if you're going to do the easy thing, do the reboot. Fine. If you want to do a little more subtle, a little more targeted, you can tell the SSHD to restart itself using the system.ctrl command. Right? Okay.
So now, it does look like we have a clarification on that question. So
shoot.
It is, can you create a GUI C# program to run on the Pi?
Yes. Absolutely. In fact, I'll have to look into exactly how you do that, but at the very least, the Xamarin guys will run on there, and depending upon how GUI you want it to be, there's a couple of ways to do that. But let me jot that down, because I will get you a better answer on that. Let me jot that down. Woohoo. And the reason I don't have the answer for that directly is because most everything I do is either I'm running system or daemons or something along those lines, or something very minimal. So okay, I'll write that down. I will, if you follow me on Twitter, I will, or Twitch, I will answer that question there for sure. Or if you were to send an email to me, I will respond to you directly. Not a problem. All right. So now what? So the other thing I forgot to tell you was you need to install the remote debugger on the Pi. This is where all the fun stuff comes in, and this is why you need to have that root access. Well, there's two reasons you need to have it. This is one, when you're attaching to other processes, you need to have root access to be able to do that attachment. And the Visual Studio VSDVG will be running as root to do that. The other one is when you're accessing hardware, which we'll be doing in the next demo, because you're accessing from a user space down into hardware, which means you have to go through the kernel and a bunch of other things. By design, you need to have system level access in order to access those things. So that's why you have to do that root login, as ooky as it feels. But this is only for debugging. Once it's in the real world or deployed, you can set up your permissions to do better. All right. Yeah, no, I've been rambling on, haven't I? So let's just see some stuff here. Let me break that out of there. So we're going to do a couple of things now. So let's get out of here. If I could type. I don't know how many eyes are watching me right now, but I don't type well anyway. It goes up exponentially as I'm doing. So I've already compiled this. You're like, okay, I compiled that. What is this? Who's talking to me? Nobody. Got it. I've already compiled this, and I've already got a project set up. I've already done all these things. So this is what my program looks like. Let me get rid of this for a second. I started with the console. .NET new console, gave it a name, which gave me a bit of a main. I added a few things in there. One of the things, the system.device.gpio. In order to make that happen, There you go. In order to make that happen, one of the niceties that you have in Visual Studio versus Visual Studio Code is that when I'm looking for that, I can do a control dot and have that go and install that package for me and other things. In Visual Studio Code, you currently can't do that, or I couldn't find a way to do that. So I need this system device.gpio. This is how you access the GPIO pins on the Raspberry Pi that I was pointing out. And that's a package all by itself. So you just go down, you copy that bit of text, you go over here, paste it, hit the go button. It adds it in there. I've already added it in there, so I'm not going to add it in there again. And to prove that, really? All right. There's the package. I actually added two packages, one for logging and one for GPIO. Added in there, and then just like every other thing you've ever done in .NET 5 or in the .NET 3.1 even. And so what I'm going to do is we're going to set up the GPIO. We're going to then move up a controller. Then we're going to do we're going to set one of the pins as input pull up. And if everybody in the audience knows what input pull up actually does, awesome. And if you don't, well, I got another talk to give you. This is fantastic because it's hardware. So basically the end result for programmers is that when I go read the state of that pin, it's going to show a 1. If I were to push the button, it would show a 0, the way I've got it wired up, because I've got it wired between ground and that pin. And so basically when it goes to 0, that means I push the mouse button down. You could look at that. You could look at it that way. So the button's pressed. So, and every time currently the way this works, you got a poll. So every 10th of a second, I'm polling all the things, which kind of bugs me a little bit. There's got to be a better way to do that. I couldn't find one yet. I think it's coming in another release. I know you used to be able to do this under the UWP programs with delegates, but for some reason they've taken that away. I'm not sure why. I've got to go understand what they've done there. But every 10th of a second, as it's rolling through here, I check whether the pin value is low. If it is, that means I pressed it, and I'm going to say button pressed out the command line. Ooh, ah, right? Fantastic. So here's what we're going to do with this. I'm going to open this up because I know a couple things are going to happen. I'm going to go ahead and say, look at this launch JSON. Before we go very much further, let's run this thing. I've got two possible configurations to run right here. We're going to launch the console and we're going to tell it to run. Now what you're going to see happen, you're going to see it go out, you're going to see it build. And after it gets done building this, you're going to see it pushing everything from, everything, and you'll understand why in a second, from my local Windows box all the way over to the Pi. And then you'll see it begin to run. And while it's working, this launch.json is something that has to be there to make that work. And it's in .vs code. You need two files here. One's launched and one's task. And we'll look at the launch real fast here. So that's my name, whatever I want to call it. I'm going to do a core CLR. My request is launching. I got a pre-task of publish. We'll go find out what that publish means in a second. I've got a command I'm going to run once it gets over to the Pi and what argument I'm going to pass to it. Remember I showed you with the hello improving DLL? It's simply what we're doing. We're doing .NET DLL. What my current working directory I want it to be when I get over there. And I've got a workspace. Now I'm going to say, how do I get there? This is the interesting part. This part here is the very interesting thing. How do I get there? These are all Linux at the top. This is all Linux pass. Oh, got an error. Dang it. Dang it, I didn't know that error was going to show up. Actually, I did. I wanted to show this error for a couple, 2 or 3 reasons. One, this error is not coming from my local box. This error is coming from the Raspberry Pi. How did it get here? It fired up the Visual Studio debugger, and that debugger is responsible for sending commands from my instance here in Visual Studio Code to the debugger and monitoring the process that's going on and watching things. So now I've got that error, and that's a very generic error. you'll probably hit this if you've not done one of these things before. And that error in general means that you do not have permission to talk to the GPIO devices. Hence, you got to do this as root. You got to do this as root. So there's ways to fire this up at root. We're not going to fire it up that way this time. But as you can see, it tried to run with my output down here, but it couldn't when it actually tried to go do something with the controller. I didn't handle this exception very well. Again, that's not what I'm trying to demonstrate. But it certainly needs to be trapped and can be handled more gracefully than what I did here. But you get stack traces, all the stuff that you'd expect to do. And I don't need that now. I'm going to say stop for the moment. We'll continue through the launch.json so we get done with that, and then we'll go show you actually debugging on this thing. So this is the important part here. Remember this part up here, these are Linux paths. This is the Windows path that you're on, and this is the program you're going to use, escaping the slashes. Yeah, fun there, right? And this is the password I'm going to do. So the same thing that you saw me type over here is basically that command and the arguments I pass into it, and this is where my Visual Studio debugger is. We'll come back to the other part of this file before. Yeah, we'll come up to the top part of this file in 1 second. I want to go back. I want to go into the tasks now. I've got 2 tasks in here. I've got a build and I've got a publish. We look at the publish because we know we called that. It's going to be a shell. It depends on build. Look at that. It depends on that task up there. I'm going to always show a presentation layer. So this is where these windows come up down here. I know where my current work directory is, and I'm going to call a command from my CWD publish.back. Ooh-ah. We'll come back to that in a second too. So in the build command, it's going to say .NET build and then my project file. Just it's straight like you typed it on the command line. Nothing special, nothing crazy, just tasking. You can make these things really robust if you want to be. This is very simple to do. For instance, if I wanted another, that's in a task. The task doesn't have this. If I wanted it in the launch, you do have you get a few helpers. Like if I want to add a configuration here, I can add. There's a bunch of pre-canned configurations that I want that I could add. Yeah, that they've done, but they haven't done everything. It helps sometimes to do that. All right, and so that's how you build one of these things up. I will tell you, I looked long and hard to figure out where to put these things and how to go and what they look like. And but this already exists for you in my GitHub repo, so you don't have to look so hard. You'll have an example of something that works. The other part up here, we're back in launch.json. The other part up here is the attach. So we're going to do something slightly different with the debugging here, because one, I want to run it as root, and I want to show you the debugging things where you can attach to a running process, not just what you launch. So if you've got some daemon running out there, some process running out there doing, and you want to attach to it to see what's going on, you will be able to do that. So I gave it a name. It's still a core CLR, and that's this time not launching, I'm attaching. And the process ID, I could specify a process ID here if I wanted to, but how do I know what process ID is going to be on? I may know what it is, but I may not. This gives me the ability to then pick it off the remote. Again, the same thing, the fun stuff's going on here. It is slightly different. You have an SSH command. You have an I that says, hello, I use this identity, and then use this username and machine, but with that identity so it knows how to do it. And when it's all that's said and done, you know, I really wanted that to go away. Here's what happens when that goes on. I'm going to come over here. I'm in my push pop link, right? I'm going to say, I'm going to go into my binary directory because I've already done all the stuff I need to do. And I'm going to say sudo, because I want to run this around, run this as root, push blink, tell it to go. Now I've got a process running, and it should come around just a second. Really? There it is. It took a little second to get there. And in case you're wondering, yeah, we used a little bit, huh? All right. So every time I push this button, see as I push you don't see me pushing the button, but trust me, I'm pushing the button. All right. Maybe I can, yeah, hold on a second. Yeah. Pushing the button. Ooh, right. Just so you see me push the button. So it goes up there. So what I'm going to do is, because that's working the way I want it to, come back over here. Remember, I'm on the Windows box, right? And I'm going to drop a breakpoint. I'm going to hit F9, drop on a breakpoint, and now I'm going to push the button. Oh, come on. Oh, it doesn't work because I didn't attach it. Selecting a different one, selecting attach, hitting the go button. Give it a second. Now I have all the processes that just came up. I can look for my one that I care about. Yeah, it was going to be 51973. I knew that was going to be the process number. Yeah, right. And so now I'm attached. It says I'm running. I have threads that are running underneath it that I can pause. I know I've got a breakpoint set in my program CS. I've got watches and variables. I hit the button and I've now broken. And I've got locals that come up with pin values on them. I have Booleans that are done or false. I can also, if I were to head over to grab the status of things. Come on, there it is. It just took it a second. I've got my evaluation going on there. If I want to look at the button pin, I've got my interpolation, so I know what it is. And I've stopped it. I know where I am. If I want to step through, step over, I can do that. It's not a lot of fun in this one. I can tell it to go again, and then when I'm done with it, I can detach out of it, and now I'm done. I'm cool, right? So now my program is going back to running as I push the button without being broken, and I've been attached, and it's all due to setting up the SSH to log in. If I'd not done that automatic login like that, I'd have had to answer a bunch of questions, basically typing in passwords forever and ever and ever, and that's just a pain. It's just a pain. So cool, huh? I thought it was cool anyways. Okay, we're getting some down on some time. Yeah, we are. So there we go. Now let's talk about this talking head. Here's some ideas about the talking head. Now I'll open up I'll pull up the overhead here in a second to show you a little bit more in detail about that. It is a C# application. I started with .NET new worker, gave it a name. You can go look at the repo as well. It's controlled by the system. At boot time, it fires up. At boot time, it fires up along with it in sequence to how I've decided how the operating system wants to fire it up. When it goes to shut down, it gets a shutdown trigger to go do anything shut down right before it happens to have to, the operating system goes away. It plugs into the operating system directly. The same way it would do on a Windows-based box as well. One of the things that it does is when I hit the button, you hear it fires off it picks a random bit of text, goes out to an application that's just setting out on the file system, forks it off, execs it, passes it in the string, and then you'll hear the output like, "Hey, talking head."
I'd agree with you, but then we'd both be wrong.
Yeah, I'd agree with you, but then we'd both be wrong, right? Yeah, I got you. So talking head is kind of surly, and then the button is doing the exact same thing that you just saw me do, a little bit different, but basically looking for that button push, right? And here, let me see if we can show you some of that goodness. Make sure I'm on the right screen. Okay, so you see the talking head. Eyes moving around. Yeah, kind of creepy. Yeah, kind of creepy. Pushing the button. Really?
Without a doubt,
Yeah, I got you. Got another one for me?
that is the best idea I have ever heard.
Yeah, I got you. So the mask itself is from Thingiverse, and I just printed out. It's meant to be worn on a human. I printed the base so it fit into it. All the fittings I needed. I modeled them up. You got a Raspberry Pi 3 here at the back of it, and you can see the back end of it. How it's all plugged together. This back end part is a kit from Adafruit that you can get, and you too can do this crazy stuff and be scary if you want. I hope somebody actually goes and does this. And the little joystick here, when I have it enabled, moves the eyeballs around. So that's how that talking head works. That's how that goes and does that. So let's. And any questions on any of that? If you're watching me on Twitch, you just saw all that being built together. And all the head scratching I did about, well, how am I going to do this next? All right, so to finish up, because we're getting close to time. These are my asks. I ask that you go install .NET 5 and write a program or two. Go grab a Raspberry Pi, throw some parts and build something fun. You know, there's if you want an idea of hey, what should I actually buy? I don't know how to do any of this stuff. Send me a note, because that's send me some feedback. You can send me and I will reply to you directly. And because this is just a lot of fun. I mean, hardware is fun, software is fun, but when you combine them both, I think you do really, really fun things. So I'm going to ask that you follow me on Twitch and Twitter, because that's how I respond. And as far as Twitch goes, Monday, Wednesday, and Friday, 8 to 10. I'm twitching out, doing various things. If you happen to watch my Twitch the last few times, you would have seen me building up this talk and scratching my head about how this works. Not as slick as I appear to be today. That's a joke, by the way. So if you don't want to send me some feedback, I would really like it if you found something different, or if you want to make my demo, help me. I say make my demo better. Help me make this a better presentation, or give me suggestions. Create an issue on the GitHub and submit a PR, because I'm always open for help. I'm always learning. You learn from everywhere, and that's yeah, you learn from everybody and everywhere you go. So I'm never afraid to ask for help or somebody to give me their opinion on how we could be better, because it usually is better. I have a number of links. Again, my GitHub repo, where to go download .NET 5, the manual steps that I was following. Scott Hansman did help with the launch files on there, believe it or not. You know, he's a helpful fellow. And there's where you get the Adafruit eyes at if you want to go do that. And the Talking Head project is there. It is a work in progress, but right now I'm comfortable where it is, and I need to add some more things to it and clean up the GitHub repo. But that's about it for me that I have to show. Any other questions, or are you going to send me some feedback, or those sorts of things?
So the last question that was put out there seems to be on the same train of thought as the other GUI questions, but it was specifically Blazor for the GUI. Can you do that?
Oh, absolutely. Absolutely. I know the answer to that. I did a Blazor talk a few bits ago, and you can do, in this case, as we're doing this, if I wanted to go do this in my examples, .NET new, and if I, just before I do this command, this is on the Linux box again, this is on the Raspberry Pi. These are all the base level templates that you can do right now. In this case, we want to do the Blazor WebAssembly, right? You know, I haven't tried to do this on this, but it will work. There may be some more setup. So let's do the WebAssembly app. See what that does. .NET new Blazor WASM dash name. We're gonna call it BWASM. Now, more than likely what it's going to do, it's going to fire up a web service that we can go hit. And we will try this real fast. Because the other thing that I've done, and Miguel has this thing called that does incurses for .NET 5, which is really cool. And I need to play with that some more, but that's all. It's all like a text-based user interface. See, we got the same sort of stuff. There, right? Imports, Blazor, all that kind of junk, right? .NET Run. If I'm really, really lucky, we will get something fired up that will be serving that, and then we'll hit it with a web browser. May take a little while longer. Let's go see what our Pi's doing. Oh yeah, we're cranking on it now. Okay, so it says localhost 5000. You know, there's a way around that. The thing I did not show you, once you get the remote stuff set in, I can say new SSH to connect the host. And I'm going to connect up to it. It'll give me a new window. This is the other way to do development, is that now I'm on the remote host. And remote hosting, examples, okay, that's fine. Where did it go? Yeah, that's the connection, targets. Nope, it's not what I want to do. All right, I'm not prepared to show this up. What you need to do now, what we need to do now, is to set up the local host. Where did it go? Where did it go? SSH targets, I don't care about that. Remote targets. No. Okay, what I'm going to have to do is that localhost 5. What, can I hit it from here? I doubt that I can hit that. You think I can hit that? If this works, I'll be surprised. Yeah, I'll be surprised if that works. 192.168.1.5000. No, refuse to connect. It'll be some more setup, but if I was running localhost on this, I should be able to hit those and I'll get my Blazor WebAssembly straight up and working just like any other application. Hope that answers your question. I'm sorry I couldn't show it to you. I wasn't really prepared to do all the port forwarding. So what you're going to want to do here is when you get connected, there'll be a way to forward a local port from the host back to your local machine. So when you hit localhost 5000, it actually gets forwarded through the SSH tunnel to the local host on the Raspberry Pi, and it'll show up. I hope that helps.
And you have no more questions, but you did get one comment that someone already has eyes, joystick, and a Pi sitting on their desk.
Fantastic. Fantastic. And if you want to, the repo is not fully fleshed out, by the way, for that, but you're welcome to use anything and everything that I have, by the way, and send me some notes on that. Okay, yeah, I can't do that. That kind of thing. So anyway, I don't know anything else we got going on. So thank you for spending a little bit of your life with me today. Hopefully it was at the least entertaining, and the best you got something out of it. And maybe my hope actually is that I've inspired enough some of you to actually go try some of this stuff and figure out whether you like doing it or not. I sincerely hope that. like I say, whether it's from my failures or your successes, I hope you learned something today. And I really do mean that. So I don't know that I have anything else, James. And just for,
Okay.
yeah.
And we'll end here then.